Dear students, we have already discussed definition of physical change. Now let's discuss each property given in the definition in a little more detail so that we can have a better understanding of physical change. First property of physical change is, as it is a part of definition as well, that change is temporary and reversible. For example, melting of ice. Have a look at the experiment, a very simple experiment which you can demo on your own. That is, take a glass of water and then take the ice tray out of freezer, put the water of the glass into the ice tray, keep it into the deep freezer, leave it for an hour or 2 hours, take it out, you will see that liquid water got converted to solid water, that is ice. Now take the tray with ice out of the freezer and keep it on a place like on a table, dining table, etc. anywhere. And after some time you will see that the ice got converted to liquid water once again. So you can see that the process is reversible. Liquid water got converted to solid water, that is ice. Solid water got converted to liquid water again. The first process of converting liquid to solid is freezing. The another process of converting solid to liquid is melting. And look at this double arrow between the glass and the ice tray. One arrow from water to freezer, one water to ice tray, and second from ice tray to water. So these two arrows between a process is the sign of reversible. This shows that water that converted to ice is reversible process. That's why ice as well can get converted back to water when cause of the change, that is cooling, is taken away. First, why water got converted to ice? Because it got cooled too much. Why it got converted back to water, back from solid? Because now the heat is given, and on heating it melts. Who has given the heat? It has absorbed heat from the atmosphere. Who has taken away the heat? Freezer. Freezer was too cool and heat itself rose from higher to lower temperature. So it got passed from the water of the ice tray to the freezer and it got converted to solid form. Let's come to the second property of physical change, and that is no new substance is formed. For example, dissolution of sugar or cutting of carrot. Now have a look at cutting of carrot. See, a carrot is cut into pieces. It's not about carrot only. It can be any fruit, apple. It can be any other vegetable like ladyfinger. When you cut it into the pieces, you look at this. No new substance is formed. The taste of the carrot is same after cutting as it was before, but the shape and size is changed. As no new substance is formed, so it is a physical change, but the difference is that you see not double arrow but just a single arrow between carrot and pieces. Why it is so? Because it is not a reversible process. The meaning is that it is not necessary that every physical change is reversible. There are some of the physical changes which may not be reversible. The cut pieces of carrot cannot be pasted by any means to make it back to the previous carrot, its shape. So that is why we need to consider all the four properties of the physical change separately, and it is not necessary that a physical change will satisfy all the four conditions. Even if it satisfies 3 of the conditions, then also it can be considered to be a physical change. Let's come to the third property, and that is individual property of substance are retained. For example, evaporation of salty water or evaporation of sugar solution. Have a look at this experiment as well. Here In the first glass, you can see the salt is added to the water. We can stir it well to mix it well. In the first one, it is sugar. In second one, it is salt. Both are the same. The process is called dissolution. In the first one, we are showing dissolution of sugar. In the second one, we are showing dissolution of common salt. And both are physical reactions because we can observe that even after the process, that is dissolution of sugar or salt, taste remains same. Sugar solution is still sweet in the taste, salt solution is still salty in the taste. And the next process is just to show that it can be separated as well by evaporation. If we separate the sugar from sugar solution or salt from salt solution by evaporation, then we get back the same sugar or same salt with same mass, same color, same properties and same taste as well. Let's come to another property of physical change on the basis of which we can consider it to be a physical change, and that is change is only in the physical properties. Physical properties like state, appearance, size, shape, etc. Like in case of cutting of carrot, the shape is changed. In case of freezing of water into ice, physical state is changed, that is from liquid to solid. In case of water evaporating to liquid salt, the solid disappears because it mixes into the liquid. So we don't see any solid sugar or solid salt again because it get converted to its smaller molecules which get adjusted between the intermolecular space of water molecules. We can't see them again. We can't even separate them by filtration. In the same way, when water is heated and it got converted into the steam, the state of matter changes. Water here, first case, is liquid and steam is the gaseous state. So the change is there in the state, which is a physical property only. Let's discuss one more experiment showing physical change, and that is heating of ammonium chloride. Look at the experiment. On a tripod stand, right? On a tripod stand, you know the term tripod stand. We have kept a wire gauze. On the wire gauze, there is a crucible is kept, or we can say the evaporating dish is kept, in which solid ammonium chloride is kept. And we invert a funnel over it. This funnel. And at the top of the funnel, there is a cotton plug. So that when the ammonium chloride get heated and get converted to gaseous form, then that gaseous form should not be able to escape out to this part. It is stopped over here. And if you don't know, then I tell you that ammonium chloride is not a normal solid. It is a sublimable solid. So on heating, rather than melting, it gets converted directly to vapor state or gaseous state. Why we are considering this experiment separately is only for one reason. That we want to discuss first that sublimable solid on heating get converted to gaseous form as the funnel is made of glass and transparent. So when we heat ammonium chloride, we see that a white fume is filled inside the funnel. So from transparent, it becomes translucent because of the white fume. What is this white fume? The gaseous state of white solid ammonium chloride. When we stop heating, then after some time we see that the white solid got deposited on the inner side of the funnel. It means on cooling it got converted back to solid ammonium chloride. So it is a change in state of matter from solid to gaseous state on heating and from gaseous state back to solid state on cooling. So change is only in the physical state, no new substance is formed. Individual property of solid ammonium chloride are same in gaseous state as in solid state, and the change is reversible. So it fulfills all the requirement of a physical change. Sublimation of ammonium chloride or any other solid like naphthalene wall or iodine or camphor etc. are example of physical change for the same reason that on heating it get converted to gaseous form and on cooling back to solid form. But there is one more significance of this. This is also an example of a physical change which is at the same time a little bit chemical change as well. How it happens? It happens in this way that while heating of ammonium chloride, in which it get converted to gaseous ammonium chloride, a part of ammonium chloride on heating get decomposed. What happens? Look here. Ammonium chloride on heating, besides getting converted to gaseous ammonium chloride, a part of it gets decomposed into ammonia and hydrogen chloride gas. So though it seems to be purely a physical change, but a chemical change also takes place simultaneously, and that is solid ammonium chloride. The formula for ammonium chloride: solid ammonium chloride on heating get converted to gaseous ammonium chloride, but a part of it get converted to two new substance: ammonia, a gas, and hydrogen chloride, another gas. So children, exceptions always exist there, and this is an exception of physical change in which a chemical change as well takes place simultaneously. Physical change is that the solid ammonium chloride gets converted to vapor state, and vapor state, that is gaseous state, get converted back to solid state on cooling, and simultaneously a chemical change takes place. Ammonium chloride on heating also decomposes means breaks down, also decomposes to ammonia and hydrogen chloride.